So, and I think now we're going to move though to our guest speaker for tonight. And we have Michael Bakich, who's come tonight and who comes periodically and talks with us because he used to live out of town and was editor for Astronomy magazine. But then he moved to Tucson, fortunately, and Holley, his wife, came with him. So Michael has been a TAAA member since he moved to Tucson, and he's been very generous with his time with us and given various presentations for us. They're always really interesting and we appreciate it. So Michael, if you're ready to start. Okay, and I think you're set up with a mic.
Test, test. Thank you, May.
Okay.
I am ready. Okay. Share screen. Perfect. Okay. So today I'm going to talk about the solar, wait a minute. There was a solar eclipse back in October. It was an annular eclipse, and I thought I'd show you a couple slides from our experience in traveling to Santa Fe. We observed from a spot that my co-author on a couple of the eclipse books that we have in our library here, Michael Zeiler, lives in Santa Fe with his wife, and we stayed with them for several days and went to an area very close to a ski resort that he uses, Vista Grand Overlook, and it was 10,255 feet, and it was spectacular. So this is a picture of some of the people that were there. There were 12 of us in our main group. We set up at this location and people just started showing up. Throughout the event, we gave a number of presentations and also looks through our telescopes, and that's Holley doing one. Holley and I set up with 2 small refractors, and the idea was that we were not going to be on the center line of this eclipse. We were actually on the northern limit so that we could maximize our view of Bailey's beads. Ooh, this is a picture that a friend of ours took. It shows during an eclipse, as the sun is continually covered by the moon, the illuminated part gets smaller and smaller and goes to a point source, actually. And so shadows get sharper. This actually shows that if you look at this line from this little device right here on top, that was at the beginning of the eclipse, and quite a bit through the eclipse, you can see that line is quite a bit sharper. And it happens with your shadow on the ground. It's one of the interesting things that you can look at during the partial phase of the eclipse. So this was, and I didn't take any of these pictures. I don't photograph during eclipses, even though I was a photo editor of the world's largest selling magazine for almost 20 years. I've never taken a picture during the 14 total eclipses I've been to, or the many partials and now 4 annulars. So this was a nice photo. There were also some prominences. Some of you might be familiar with Jay Anderson, the Canadian meteorologist who does the wonderful website talking about the weather. I'll refer to him later on in the talk. This was his wife that took this picture, Judy, and wow, just amazing. And then my co-author, Michael Zeiler, did a little bit of a video, and I'll show you just a part of it, and you'll be able to see on the right-hand side the changes in the bead structures. Now, again, Holley and I were observing with small refractors, and we kept, basically screaming at each other, oh, there's another bead, oh, look on top, and this and that. And we eventually saw 7 minutes of Bailey's beads. I was hoping for a minute, maybe a minute and a half. We observed Bailey's beads for 7 minutes. In all the eclipses I've been to before, my total count certainly doesn't come up to that. So this was a really wonderful trip. Okay, so today I want to talk about the great eclipse that's coming. We can call it the Great American Solar Eclipse. We just had one 7 years ago, but this one's even better. But some of us may not be familiar with what an eclipse is. So what is a solar eclipse? A solar eclipse is the exact lineup of the sun, the moon, and Earth in that order. The moon's in the middle. And the moon, because this is a straight-on lineup, casts a shadow on Earth. And the shadow is actually of two parts. There's the penumbra, the lighter outer shadow. So during the eclipse, if you're within the area of the penumbra, you're going to see a partial eclipse, not where you want to be. You want to be in the darker inner shadow that's called the umbra, because only from there will you see a total eclipse. So the penumbra and the umbra, and you really want to be within the umbra. So this is really important. You have to use an approved solar filter for the partial phases of the eclipse. Okay, and you can do this in a number of ways. Okay, you can, in the picture at the bottom right, that's the most usual way these days, eclipse glasses. They're not really eclipse glasses, solar glasses. You can use them to look at the sun at any time. And then the top picture, Holley is looking through a number 14 welder's glass. Only number 14 is dark enough. So number 14 welder's glass. And then Holley in the picture at the lower left is looking through a telescope, and you can see there's a solar filter on the front of the telescope. And that's important. Whatever you're looking at the sun through, the filter has to go in front of that, in front of your eyes, in front of the telescope or binoculars or your camera. Always in front, never behind. Now, here's another thing that's very important. You must not use any kind of filter during the total phase of the eclipse, because a solar filter dims the light by something like 200,000 times. So if you're trying to look at the eclipse sun through a solar filter, you're not going to see anything. So you take the solar filter off. When do you take it off? Okay. I like to think that if you're in a group, somebody at some point, midway through the eclipse is going to scream two of the most exciting words in science: diamond ring. Okay. That's when you take off the filter from your eyes, from your binoculars, from your telescope, from your camera, because you won't see the glory of the eclipse, totality, unless you do. Okay, so do not use, this is the only time, in fact, that you don't need any type of safe filter to look at the sun during totality, and it's coming. A couple of questions I've been asked through the years, and the answers that I've gotten and what they really mean. Okay, so you ever see an eclipse, a total eclipse? Yeah, I think so. No, you haven't. I'm pretty sure I did. No, you haven't. Yeah. So most of the people that you encounter still, even after the 2017 eclipse, will never have seen anything like what's going to happen on April 8th. Okay, and that is the date of the total solar eclipse. Its magnitude is that number, 1.0566. Any magnitude 1 or greater means it's a total eclipse, because this is the ratio of the sizes of the moon, apparent sizes, of the moon and the sun. So if the moon's size is greater than the sun's, then this number will be bigger than 1. If the moon's size is less, that number will be less than 1, and you'll get a partial eclipse or maybe an annular eclipse. So this particular eclipse has the moon 5.66% larger than the sun. Okay, that means for this eclipse, the maximum duration of totality is a whopping 4 minutes, 28 seconds. Okay, that happens across the border into Mexico at a small town called Nazas. But if you're on the Texas-Mexico border on the center line, then you'll only lose 1 second off of this. It's 4 minutes, 27 seconds. And along the center line, all the way from the border to Indianapolis, it's 4 minutes or greater. Okay, so this is really a fabulous eclipse. The average time for totality during a solar eclipse is 3 minutes, 42 seconds. Okay, 3 minutes and 42 seconds. I figured that out on a day that I didn't have anything to do and did a lot of calculations. Interestingly, the first record that I bought was a record by the Rolling Stones called Jumpin' Jack Flash. I don't know if any of you remember that. Its running time was 3 minutes, 42 seconds. I don't know. I'm sorry? Running time. Yeah, the song's running time was 3 minutes, 42 seconds. Yeah, on the record. We're 94 days away. That sounds like a lot, doesn't it? I started my countdown timer when we were 1,500 days away. And now we're only 94 days away from this great event. It's not a lot of time to get ready. I mean, if you are trying to find a location to stay, I'd do that very, very soon. Yeah. Okay, so here's the entire path of the eclipse. And in the United States, 31.5 million people live within the path of totality. That's a lot more than in 2017. In 2017, 12.25 million people lived in the path. More than that number live in the path before the eclipse leaves Texas. Okay, 31.5 million people. All they have to do, weather permitting, is step outside, look up, boom, eclipse. Okay. Let's take a look at the path of the eclipse. Here we can see the US-Mexico border, and I'll try to use my cursor here. So the eclipse comes up through Mexico and encounters the US at Eagle Pass, Texas, initially. And that's a very tiny town, but it's on the border, and it does offer 4 minutes and 27 seconds of totality. So it's really, really a great spot. We continue up through Texas, and about half of San Antonio is covered by the umbra. Austin is covered, some smaller cities like Killeen and Waco. And then, why are there more than 12 million people in Texas that are in the umbra? It's because of the Dallas-Fort Worth metroplex here. And you can see it's pretty much totally inside the path of totality. Now, if you're on the northwestern edge, you're not going to see very much eclipse. But if you're on the southeastern edge of Dallas, then you're going to see more than 3.5 minutes of the eclipse. And a short drive south of Dallas by 20, 25 miles will get you an extra 20 seconds of totality. Quite worth it if you can find a spot to park. Okay, then we move into Illinois, Kentucky, Indiana. And I want to find, there's a little town in the center here called Carbondale. Carbondale in 2017 had a big event. It's the home of Southern Illinois University, and they did a huge event for the eclipse. So that eclipse started in Oregon and came down through the US and ended in South Carolina. This one goes from Texas to Maine. So So Carbondale was at that intersection point. So if it's clear April 8th in Carbondale, people there will be able to see 2 total solar eclipses in 7 years without having to travel anywhere. Really amazing. And then as we move into Indiana, the huge city of Indianapolis, totally covered by the umbra. And Ohio, we can see the tip of Cincinnati here. We can see Dayton here. And then we see Columbus there, home of the Ohio State University, where I went to school. I'm not saying I was educated, but I went to school, undergrad. And then we moved through Ohio, get to Cleveland, which is basically dead center. I'm not a proponent observing sessions or eclipses or anything like that of people playing music. In fact, as Holley will know, I almost got into a fight once about somebody playing music during one of our observing sessions. However, if you want to be in Cleveland, in the parking lot of the Rock and Roll Hall of Fame, and you want to dial up Pink Floyd's Dark Side of the Moon, hey, I'm okay with it. Okay. You know, it's just, wow. I mean, Cleveland, the prospects are not great as far as clouds. We'll get into that, but wow, what a place to see it. Okay, then we move into New York, and you have Buffalo, Rochester, Syracuse, all covered. But I want to point out this area right here, Niagara Falls. Slowly I turned. So Niagara Falls, if you're at a place there called Terrapin Point, which I think is on the Canadian side, but you can walk to it. I mean, you don't need a passport to go to Terrapin Point. And you look back toward the falls, you will see, if it's clear, and this would be the greatest photo op for this eclipse, the eclipse sun over Niagara Falls. I mean, wow, right? In 2010, we were on Easter Island for the eclipse. Similar thing. 40 degrees up is the eclipse sun, and we're looking at some of the stone statues beneath the Moai. That's a sight I'll never forget. And then we continue to move through New York and encounter Vermont and New Hampshire. Montreal in Quebec is half covered by the umbra. And then finally we get to Maine. Very few roads, very few towns, very little prospect of anybody seeing the eclipse from there. Sorry. Okay. So you found a spot. It's clear. What do you look for? Well, the first thing you look for is first contact. This is the initial bite out of the sun's disk taken by the moon. Okay. People have given me all kind of grief through the years. Oh, it's not that big a deal. Michael, what do you? It is a big deal because when you see first contact, you know you're in the right place. Okay. So all your planning was worth it. During the partial phases, if there are any trees in your area, and we saw this in New Mexico during the annular eclipse even, you can see the spaces in between the leaves of the trees act like pinhole cameras, and they will project crescent suns on the ground. It's really kind of cool, and they change, and you know, as there's a little bit of a breeze, and also as the eclipse progresses. And then, as I mentioned before, we've got the sharpening shadows. And as you get into so you're not going to notice much during the first half of the eclipse when only half the sun is covered. But as you get into the 90% covered range, then your shadows really are going to start to sharpen. And then it happens. Somebody screams, and if you're with me, it'll be me. Diamond ring. Okay, this is the last tiny fraction of the sun's brilliant disk, but it's such a small part of the disk that we're starting to see the corona around it. And it really does look like a diamond ring. It looks like that in the sky. So the main part of the eclipse is now starting totality, well, nearly totality, from diamond ring at the beginning of totality to diamond ring at the end of totality. What else? Well, Bailey's beads. You're not going to see 7 minutes during a total eclipse unless you're on the edge. And I don't advocate that for a total eclipse ever. Fine for an annular eclipse. But look for Bailey's beads. You'll probably see maybe 10 seconds, 15 seconds or so of Bailey's beads. Not very much, but enough. Then there's the color layer of the sun called the chromosphere. Now, I've been to 14 total solar eclipses. I've seen this 4 times. Okay, so it's tough to catch. And at this point, I'm using binoculars to look at the sun. Okay, and so you might see this, and it's fairly intensely red edge of the sun called the chromosphere. Finally, the Latin word that means crown. The sun's corona appears, and it is really something. To see the corona in a fairly darkened sky, just amazing. I mean, it's sometimes life-changing for people. Now, during totality, take just a few seconds because, you know, the main event is in the sky. Take a few seconds to look around, especially at the middle of the eclipse, and you'll see the 360-degree sunset because, you know, you're in the middle of a huge shadow cone. So on one side of the cone, sunrise is occurring, and on another side, sunset is occurring, and you're in the middle, and it's really cool to look around and see this 360-degree sunset or sunrise. There were also a few other things in the sky with the sun during totality. Now, there are more on this chart than you'll be able to see. The 2 things you will be able to see are Venus and Jupiter. Venus blazing away at magnitude minus 3.9. You'll see it probably 10 minutes before totality, maybe even a little bit more, even before, you know, the beginning of the total part of the eclipse. Jupiter is only a fifth as bright as Venus, but during the eclipse, it will really shine forth. You won't have any trouble seeing it. You might see it a couple minutes before totality, and both of these objects will be visible after totality longer because you'll know where to look, okay? The other objects in the sky, you know, Algol, Hamal are 2nd magnitude stars, forget about those. Mercury is close to the sun, maybe see it through binoculars, but it's fainter than 4th magnitude. So not bright at all. And Saturn and Mars, 0 and 1st magnitude, are so far away that you'd have to spend quite a while searching for them in binoculars. So don't do that. But you will see, without any effort at all, Venus and Jupiter. Okay, so every point in the 48 states will see at least 16% of the sun covered. And that means in the northwest part of Washington state. Okay. Well, what about the old Pueblo? Okay. Here in Tucson, I was about to say I won't be here. You will experience a 69% partial eclipse. Okay. Now I know there are a lot of amateur astronomers in the audience, but some of you may think, ooh, 69%, that's pretty good. No, it's not. Okay. I don't know if you were here for my last talk. I live by 4 words. It's all about totality. Okay. Nothing else matters. 16, a 69% eclipse. If you didn't know that an eclipse was going on and you walked outside, you wouldn't even notice it. Okay. Because when 69% of the sun is covered, it's still 310,000 times brighter than the full moon. Okay? 310,000 times brighter than the full moon. So a lot of light. The sun is very bright, even 31% of it is really bright. Okay, a few tips. If you travel to the eclipse, probably know this, get there early. I liken eclipse travel to a zombie apocalypse, except it may be worse because zombies don't need food, they don't need lodging, they don't need good roads. There are a lot of things zombies don't need that we do. So get there early and actually stay there throughout the eclipse, because the worst traffic you'll find will not be in getting to the eclipse, because as an amateur astronomer, you'll know to get there several hours early. Most people won't. Okay, most people will try to arrive right at the time the eclipse is going to start, and they will leave as soon as totality is over. Oh, it's getting brighter, time to go. You can still see a lot after totality. So plan to stay after totality, because believe me, that's when the traffic really gets rough, really rough. Okay, solar safety means sunscreen. I know it's April. Well, I don't have to tell you that. You live in Tucson. So April is, you're going to be out under the sun for 3+ hours at least, and however early you get there. So please take as good a care of your skin as you do your eyes and protect it. If your sunscreen, by the way, is more than 3 years old, toss it and buy a new bottle. Okay, so don't do this. Remember, the filters always go on the front of whatever you're using to look at the sun. Now, if Holley wasn't holding the binoculars in this picture, she'd be fine, because her eyes would be protected by those glasses. But the binoculars would focus enough light to burn a hole right through those glasses and blind her. Now, we took this picture in Milwaukee, where it's pretty much always cloudy, on a cloudy day, and she wasn't even looking in the direction of the sun. So we were really careful. I just wanted to make a point here. Never do this. And never do this. Okay, make sure, because you don't know what the weather is going to be on eclipse day. You may have to move relatively quickly. So you don't want to, two things, you don't want to run out of gas, but you also don't want to get into a line, where you have to wait to get gas. So keep your gas tank as full as you can for as long as you can. And I've said this before, 10 minutes before the eclipse, before totality, is not the time to use the bathroom. Okay, it's just not. And I've said this before too. If you have young children, okay, and little Jennifer looks up and says, "Mommy, Daddy, I need to go to the bathroom 2 minutes or 3 minutes before totality," you need to steel your resolve, look at her and say, "Go in your pants." Just saying. So be prepared. Try to get this out of the way well before totality. Okay. So as I just said, I can't, certainly, nobody can tell you what the weather at any site along the eclipse path is going to be on eclipse day. We don't know. Weather is a short-term phenomenon. But we have a lot of climate statistics. So climate is long-term. Climate is what should happen. Weather is what does happen. I had a good friend who's the TV meteorologist for the ABC affiliate in Kansas City. And I once asked him, I said, "Brian, how good are your forecasts? I mean, how far out?" He said, 2 days, usually, maybe. And I looked at him and I said, "But you give a 7-day forecast each night." He said, "Yes, I do. And that's because the other 3 stations give 7-day forecasts." So climate is a good indicator in a general sense. And I want to show you the past several years of the eclipse path. And so here is 2017 on eclipse day. You can see Texas is kind of clear and maybe Ohio. Here was 2018. Again, Texas fairly clear, Ohio fairly clear. Again, 2019, pretty much only Texas. 2020, not a great year, but those clouds are broken enough that probably a lot of people would have seen it had it been on that date. 2021, pretty good, except for Illinois, Indiana, and Ohio, even up in the Northeast, which is rarely clear at this time of year. And then my last one is 2022. Let's not hope for this. Okay. So this is, that's a look at some of the climate statistics. And you can see that the farther you are to the southwest, the better your chances are of encountering clear skies. Luckily, we live in the southwest, so we probably wouldn't be driving to Indianapolis or Buffalo, or any place like that. Would be going to Texas like we are. I mentioned Jay Anderson before, and he did an interesting study that I want to share with you, and it deals with El Nino. Okay, El Nino. And I won't go into his whole methodology or anything like that, but he found something interesting. So this is the overall cloud map for April 8th, okay? The median cloud amount. You can see the bluer the area, the clearer possibility. Again, this is climate, not weather, okay? And then he just took the years that were affected by El Nino. Take a look at this. He found that from Texas through Arkansas, the median cloud amount dips by 5 to 15%. Okay, so El Nino is going on. We don't know how strong it's going to be, but El Nino is going on in the Pacific. So we're hoping for a strong one because this would be great. And that was a surprise to him. Certainly was a surprise to me. So we've talked about where, when, how long, some tips, but I'm telling you, you should plan for the eclipse. What's our plan? Okay, what's our plan? So I'm calling this the San Antonio Eclipse Expedition because we have a house in San Antonio reserved where we're going to base. Okay, we're going to base in San Antonio. And there's Holley and me and 7 other people, friends here in, 4 of them are friends here in Tucson. And then Holley's parents and her brother are coming down from, her brother lives in Missouri and her parents live in North Carolina. So they're coming down and they'll be with us in the house. So not going to observe it from San Antonio. Plan 1, okay, will be to go to Ingram, Texas. Okay, it's only 74 miles away. We'll leave really, really early in the morning. 4 minutes, 26 seconds of totality. Okay, a little further away, but we get an extra second of totality, is radar-based Texas, right on the border, right by Eagle Pass, but it's 152 miles away. So those are both to the southwest. Then if that area is cloudy, but the northeast is clear, we could go to target number 3, which is Gatesville, Texas, 164 miles, almost as much totality. Or if it's just really crazy and we have to drive quite a ways, we may go to Sulphur Springs, which is 350 miles away, but also 4 minutes, 21 seconds of totality. So that's our plan. We're going to stay in San Antonio at this house for a couple of days. And then early eclipse morning, we're going to get up and we're going to drive to one of these locations, whichever one looks the best. And I would suggest that you have a similar plan. And right now, I'm in the process of trying to contact various places in these cities or towns, to set up, can we park in your parking lot or just things like that. see this eclipse, because after this one, in the continental US, it'll be 20 years before we get another one. And that one ain't great. Okay. Here you can see that it only touches 2 states, North Dakota and Montana. And just not that great. Now, the following year in 2045, there's another fabulous eclipse that goes from California all the way to Florida. And if you're in Florida, if you're anywhere in Florida along the center line, you get more than 6 minutes of totality. So that's 2045. So just remember the 4 words I live by. And in case you don't remember this slide, remember this slide. It's all about totality. Okay, it really is. Quick commercial, buy one of my books. But if you're cheap and you want to see Holley and the bread line, they are available for checkout at the club library here. That, as they say, is that. Thank you very much. Okay, May is going to wander around. If you have any questions, maybe a few lights to help her not trip.
Right. Okay. Do we have, yes, we do have a hand. I'm on my way.
Ooh, get that up.
Okay, here you go.
Thank you. I thought I was listening carefully, but I never heard the time of day that totality will occur at the various locations on your path.
Okay, in Texas, and it gets later as you move toward the Northeast. But for example, in Ingram, Texas, where we're planning to go on the center line, the eclipse starts at 12:14, so a little bit after noon. And then, you know, as you go further, and then you're encountering time zones, and it gets later on the clock, but not much later in the actual sky.
So when you were looking at the chromosphere, then you said it was a beautiful red.
Yes.
That was with or without a shield? Yeah.
Without. Okay, at that point, you don't need a solar filter. Okay, and I've been asked before, you know, when is it safe to look at the sun? And I would say diamond ring. When you hear, or you know, maybe see that through your, and it'll be the last thing that you see through your glasses. When you can't see the sun anymore, take them off and it'll be quite safe.
Okay, another question?
All right, I'll trip to this question and exhibit my lack of knowledge.
Not at all.
What is a Bailey's bead?
Okay, Bailey's beads are little dots of sunlight along the edge of the moon. And what causes them is the moon has mountain ranges. Okay, so if there's a mountain range on the edge of the moon, sometimes the last little bit of the edge of the sun can peek through the valleys. Okay, and from our perspective, they look like bright dots along the edge of the sun. They're called Bailey's beads because the English astronomer Francis Bailey was the first one to describe them. Probably not the first one to see them, but the first one to describe them in, I think, 1837. And that was during an annular eclipse. It wasn't even a total.
Okay. Here we go.
Oh, yes. Are shadow bands still a mystery?
Pretty much. Shadow bands are these undulating waves of light and dark that you sometimes see before totality. And they have to happen when the sun is an extremely thin crescent. Again, I've been to 14 total solar eclipses. I've seen shadow bands twice. Once I was looking for them, and once in 2019 in South America, wasn't even planning on it. And all of a sudden, wow, there they were. So best seen against light ground, or dirt. Sometimes people will actually lay a white sheet out in hopes of seeing them. But yeah, pretty much a mystery still. I mean, it's a refraction that happens within the atmosphere, but
Well, thank you very much for reinforcing my position that my family should not be going to Rochester for the eclipse. I will relay that to them.
fair enough.
Though they bought the hotels over a year ago at this point, so.
That may be the only clear spot in the whole path that day.
Rough. My question actually, I'd love your opinion on this as I guess, a former photo editor. Would clouds actually enhance an eclipse in some way, at least an annular eclipse?
Sometimes they do. Let me give you an example. Let's see. This was, let's say, 1998. I was in Chile leading an eclipse group, and there were some really high, thin cirrus clouds overhead. The eclipse wasn't really changed at all in its appearance. However, what we did see because of those clouds was the shadow approaching overhead. Really, it happens really fast. Sometimes you can see the shadow if you're high up and you're looking like in a valley or something like that, because I mean, the shadow is traveling between 1,500 and 3,000 miles an hour, depending on where you are along the path. We actually saw the shadow come overhead, and it was something. It was startling is what it was. I'd never seen that, never experienced that before. So sometimes the clouds can do things like that. I would probably not want to observe through clouds at all, if that's my choice. I'm sorry? The shadow moves at the same speed. Yeah. So it's moving, when it's at the start of the eclipse is generally slower because it's more overhead. And as it gets farther along in the path, it's going along the curved earth. So it's speeding up. So in the US, I think it starts around 1,500 miles an hour, roughly, and ends in Maine. It's going about 3,000 miles.
Okay, another question? Yeah, a hand behind me here, so take me a minute.
These are really good questions. Thank you.
When we saw the 2017 eclipse up in northern Idaho, at the point of totality, and as you went into it and came out of it, there was a noticeably perceived drop in temperature. I assume that was due to the blockage of UV light.
That's correct.
I didn't have a thermometer, so I couldn't really check the temperature. Do you happen to have any data on how much the temperature falls during totality?
It definitely does. I mean, I mean, it's not just the light of the sun that's blocked out, but the infrared, the heat that we're receiving. The annular eclipse back in 1984, I was in Louisiana to observe that. And I actually had a thermometer with me, and the temperature dropped by 23 degrees. I mean, so I'm sure that the humidity, in wherever your observing site is, has something to do with it, and, your elevation and things like that. We saw a noticeable drop during the annular eclipse. We were already at 10,000 feet, but I mean, wasn't a cloud in the sky. I was in short sleeves, but when the temperature began to drop, I put a jacket on. It was noticeable. I don't know that anybody in our group actually recorded how much of a temperature drop there was. Oh, and there's another thing that happens, and it actually happened here in Tucson. We have a solar array, okay? And you can see the graph the dip in the power that the array was producing, during the annular eclipse, and I'm sure it'll happen again during the total eclipse. So yes.
Okay, other hands in the room here? Other questions? Looks like maybe, Jim, that we have got the questions in the room. Do we have some other questions online here? I think they're coming up. Okay, and I'm coming with the microphone.
All right, several comments about great presentation. Ken asked, can you use binos with the diamond ring?
Yes. But not before. It's a little dicey, I honestly, um, you know, I have again observed 14 total solar eclipses. I've viewed the diamond ring, with just my eyes, through binoculars, and I can see you just fine, ma'am. So,
Which eye? The good eye?
yeah, with either eye.
Okay, well, hang on a second, Paul. Let's finish up here and then we'll get the microphone to you. Another question on Zoom. In 2017, there were rumors of sales of fake eclipse glasses being sold. Are you aware of any documented cases of injury?
I am not. And that's one of the cool things about solar eclipses. People are generally fairly reticent of, about looking at the sun. The only thing that I tell people, imagine that the glasses I'm holding are eclipse glasses. Okay, there's a right way to use them and a wrong way to use them. The wrong way is, oh, there's the sun, and put them on. Okay, the right way is put them on. Then the only thing you're going to see is the sun. So, but no, it takes a while. I wouldn't share this with a general audience, but it takes a while for the eye to become damaged by the sun, a number of seconds. Now, for young children, that number is way reduced. So you really have to be careful if you have young children with you. But at my age, I could probably stare at it for a day and
You'd never notice.
no change.
All right, let's see. Byrne asked, Patty and I plan to view the eclipse from our backyard in Yellow Springs, Ohio. Okay, good. I guess that's hopefully a good spot. Maybe, we'll see.
Yeah,
Time will tell.
I don't remember how close it is to the center line, but you'll get over 3 minutes of totality there. Sure.
Yeah. Dennis asked, any guidance regarding this? Is it plausible to drive from, say, Austin, well ahead of totality, to an anticipated clear site along the line of totality and pull off the road somewhere and set up and wait until the point of totality, trying to avoid an appearance of trespassing? Have fun with that one.
Yeah. The diciness of that question speaks for itself. If at all possible, try to get prior permission to park, where you can. I mean, if it's a state park or a national park, you're probably okay. Just if there's an entry fee, you pay that and you set up anything you want. But and you definitely do not want to set up along an interstate, although I guess a rest area would be fine. That would be fine. That would be the only place along an interstate or a major highway that you could set up safely.
We have one Facebook question.
Yeah, this Facebook question comes from Kim, and she's wondering how to find a copy of a detailed map to check out places to go and the times it will happen.
Well, I mean, how self-promoting should I be here? If you go to Kim, if you go to the website greatamericaneclipse.com, you'll find maps, you'll find books, some of which I wrote the text for, about the eclipse that will give you all the information that you'll need.
Actually, I have a couple of questions here. The one that came up. What would be your take on, first of all, when you look on a road atlas, on a map, even some of the, similar to rest areas on the interstates, like say a state highway or a county highway, you have a little X there denoting a roadside park
Mhm.
along there. And I was wondering if that was a possibility. Forget the state parks, by the way, folks around there. I tried to get a campsite that they won't, there's not a single lousy campsite anywhere along that path of totality.
Good to know.
And
Yes.
because I tried in the beginning of November, the day they were supposed to go, become available. And they went, they became unavailable. There were like 9 sites that they were making available that day. And in microseconds, they all disappeared.
Right.
And so, but
But
what I
you-
had in mind was like, say, roadside parks
Right.
along the way that are in the vicinity of that park. Or of course, a gentleman offered to have me stay with him at a hotel in one of the smaller towns along the, it's called Fredericksburg.
Yeah, Fredericksburg, sure.
And, but the other question I have too is.
Well, let me answer that one first.
Oh, okay.
Yeah, those roadside pull-offs, sometimes called picnic areas, perfectly fine for setting up. The only thing you want to be careful about is, are there nearby trees that might block your view?
Yeah.
But it's perfectly legal for you to pull off, set up a telescope, do whatever you want there, have a picnic, stay as long as you want. Very
Oh, okay, that's good. And just in case.
Mhm.
Okay, my other question was, how far into the diamond ring would you say it would be safe before it's no longer safe? Like say at the end of totality.
Right.
Like I'm a little reluctant, I'm a little queasy about, looking too soon at the beginning. I usually just wait. The 3 times I've been to a total solar eclipse, I've always waited until it was completely covered
Right.
before I start looking.
Right.
But at the end, you might be able to still witness it if you
Yeah.
take the.
I don't know of anybody who's ever, and I mean, I'm talking about people that have been to way more eclipses than I have. I don't know anybody who's ever experienced eye damage after the diamond ring. Okay, so once the diamond, you see the diamond ring, that's the very tiniest part of the sun's face, and you can still see the corona. Okay, as soon as the corona fades, you're
Oh,
done looking.
okay,
Yeah,
yeah.
there's nothing more to
longer
see.
safe,
Look
yeah.
away.
Yeah, there's nothing more to see
Right,
after that.
right. And if I'm wrong there, I'll buy you a cane.
Okay.
Any other questions? Okay.
Not a question, but I understand that the Devil Comet will be able to be observed during the eclipse.
Don't know. Yeah. Oh,
That was information Jim got off off one of his science sites within the last couple of days.
it would need to be a bright comet, but comets have been observed during totality before. In fact, back in the day, just before I was born, that's how some comets were discovered. They were seen during totality, and some of them never again. But yeah, so it's always possible. I guess we could have a guest star come by.
Okay, any other questions in the room? Okay, looks like we've got another one online here.
This is just a comment from Dennis, I think. It says, how about parking lots, shopping centers, et cetera? I suppose the neon lights may turn on as the point of totality occurs.
Yeah, in my experience, if if you're in a spot where there are lights and their photocells kick on during totality, it doesn't affect you. It really doesn't. I mean, I guess if you're right under it, doing photography, but your eyes, within the time that totality happens, even 4 minutes and 28 seconds, there's no way your eyes are going to dark adapt. So people scream at other people because they're using flashes on their cameras and everything else. It doesn't matter. It's not going to affect you, believe me.
Okay, I'm seeking last questions. Any more on Facebook? No, and no more on Zoom, and apparently no more in the room. Well, thank you so much, Michael. This has been
Thank
so fascinating. Hopefully, we will have all integrated lots of words of wisdom here, and we'll be able to find ways to apply those. So, thank you so much. Maybe we can get together afterwards and find out how things went. Okay, I would like to, at this point, thank everyone who has been attending on social media. We really appreciate your presence. We hope that you will look us up on TucsonAstronomy.org. And we hope that you find a way to get to the eclipse and wonderfully enjoy it. So thank you so much for joining us tonight. We hope to see you next month, the first Friday of next month. Thank you.